Science Goes to the Movies, a look at the stories of science and how they change our culture. I'm Lisa Beth Kovetz. In the new flick Free Guy, Ryan Reynolds plays a bit of very important computer code stuffed into a non-player character in a massive open-world video game who achieves sentience, sort of. It's a really good, fun movie and an excellent example of all the things real artificial intelligence is not going to be anytime soon. CUNY's own Anita Raja, no, that's Anita Raja, this is Anita Raja, and she's here today to discuss what is going to be. Anita, welcome to the show.
Thank you, Lisa. It's a pleasure to be here.
What's the difference between the natural intelligence of the human actor Ryan Reynolds and the artificial intelligence of the character blue shirt guy that Reynolds plays?
Catchphrase.
Reynolds' natural intelligence would be his ability to understand his environment, learn, and also determine how he's going to achieve his tasks for the day, for the week, for his lifetime. Artificial intelligence, on the other hand, is the ability to simulate this type of learning and understanding to achieve the goals.
One just happens and the other has to be instructed.
That's right.
Anita, what exactly is an artificial intelligence?
So artificial intelligence as a field of study is, you can consider it the study of intelligent agents. And an agent is basically a software entity that is capable of receiving perceptions from the environment, the sensations. It's observing the environment and taking sensations from the environment, doing some sort of computational processing, and often this would be where there's a utility function that has been predefined for this system and to achieve a set of goals. And the goal is to optimize. How do you maximize the utility function to achieve the goals? And what are the set of actions that need to be taken to do that? And once it has determined those actions, it can take the actions now on the environment, right? So whether it's making coffee versus a cappuccino,
Excuse me?
or any other decision making, should I save this person or another person? Those are the types of actions that the agent can take on the environment. This software can be embodied within an app on your phone, or it could be embodied in a robot. Or you might even not know that it exists. It's just there in the background.
Yeah, when you say it like that, that's just not as scary as Terminator.
Come with me if you want to live.
Yeah, we're a far cry from where Terminator is, at least at this point. Yeah.
The writers of Free Guy, Matt Lieberman and Zach Penn, did their AI homework. Guy lives in a benign loop of programming, and it seems that he magically deviates from his programming when he meets Molotov and falls in love with her. But, spoiler alert, we're talking about the end of the movie. At the end of the movie, we discover that the human who wrote Guy's code loved Molotov first and included parameters that instructed Guy, if you meet the perfect girl, then you will begin to grow. In real life, can a line of programming ever exceed the code?
Yes. So it can be intentional by the developers of the code, the designers, and that's what we call integrating machine learning into the code. So when the code is able to learn and adapt to new situations and using statistical analysis and pattern recognition, then the code can do things which have been prescribed by the designer. But yet you need to have constraints and gates to make sure the code is behaving in, overall in the way that you would expect it to behave.
What are those constraints and gates?
You do checks. You say these are the acceptable types of behavior. As long as it's under this umbrella, then this is fine. You set termination conditions to make sure that if the goal is achieved, then the learning is complete, and then you move on to the next task. But there can also be unintentional deviation of code, and this could just be in code without AI or ML aspects to it. Just in regular code, the code could do things that you don't expect it to do, and that's why we need to do rigorous software testing. And again, there you are making sure the code is behaving in the way you expect it to be for a variety of different test scenarios. And this is something that is part of computer science and software engineering and software testing.
In Lord of the Rings, when Gandalf falls into the widening pit of evil doom, Frodo and his guys are too distraught to go on.
Fly, you fools!
But The creators of Free Guy seem to have a good sense of what it is to be an AI. And here's a spoiler alert. When Guy's best buddy in the whole gameverse, Buddy, played by Lil Ray Howeray, dies horribly falling into a widening pit of digital doom, the very accomplished actor Ryan Reynolds does not react like a human. Can code on its own ever just react like a human?
So you mentioned Frodo, my most favorite character in all of literature, so I have to talk a little bit about him, and it will set the context for discussing our friend Blue Shirt Guy. Frodo was such an interesting character. He is a wise person, he's honest, and he's humble, and also there's a strength of character that we admire in him. And at the same time, he's not completely perfect. He has his weaknesses, and so as the readers of the book or watching the movie, you sort of identify with him, and you want to support him, and I think there's an emotional connection that the audience gets with Frodo, and it's a very human connection. In the case of the Blue Shirt Guy, we can embed emotions in the AI system, but not as it relates to neurons firing off in the brain. It's just what we would call facial expressions that express some sort of, the situation is not what I prefer it to be. So I'm getting a negative utility in what this software system is computing for its environment. We are also might see it as something as a negative penalty that the system is getting. So what we don't see in the movie is the Blue Shirt Guy character feeling this deep sadness or despair or loss, which we would expect from a human. And that's where AI systems are at. They compute a utility function, and we can embed notions of feelings. We call it affective computing. So it's that facade of what does happiness mean, and it could be an emoticon with a smiley face or a frown. And we don't understand emotions and the depth of where they arise in humans. So we still need to go a ways before we integrate that into AI systems.
But the movie really kind of hit that in that Reynolds had a facsimile of a reaction to loss, whereas Frodo wept for days.
That's correct. And you feel that. Even the fact that they call the character a Blue Shirt Guy, there's a disconnect. You're still looking at a software system, not a real person, even though this system is going through the same experiences that a human could. I think most audience would connect with Keys because he's the background character who really is in love, who has a loss, and who then experiences love again. So emotional connection would be with Keys rather than with the Blue Shirt Guy.
In the new Space Jam, the ultimate villain is the algorithm. And we hear a lot about algorithms lately. And yeah, they can sound a little villainous when they're not crunching the numbers in your favor. But in real life, what is an algorithm?
An algorithm, informally, is just a set of rules which allows you to execute a sequence of instructions to achieve a particular task or a particular goal. And another key notion is that there has to be a termination condition for the algorithm. So you want to make sure that this is a finite sequence of instructions that are being generated. I mean, this can happen at a smaller level, right? So when you have introductory programmers who are just starting off with coding, it's possible to write code which is in an infinite loop. It's very simple to do, and your code is just running nonstop. Hopefully it's not using up all of the computational resources of an institution, but you very quickly realize, I need to have a termination condition for all the code that I write.
Do you really hammer that into your new students?
Absolutely. We definitely don't want them to write infinite loops into their code.
In most dystopian AI stories, the machine chooses on its own to stop executing its assigned task and starts making meta decisions. And usually the computer has considered all the information that's been fed into it and has concluded that its assigned mission is faulty. And more often than not, it's now time to kill all humans, which I think we all can agree is bad. But in real life, what are the benefits to humans to have machines that can make meta-level decisions?
So in my work, I define meta-level decision-making as the ability to think about thinking. So how much resources do you invest in thinking about a problem versus acting on a problem, right? And so the resources could be cost, it could be time, it could be other computational resources. It could be the time and effort spent in collaborating with another system or an agent. So let me just give you a simple example. A student is taking an exam, and it's supposed to be a 2-hour exam, and there are 6 questions, right? And some questions are pretty easy to respond to and will take less time. Others would be much more detailed. Often, if I am the instructor, the last question is going to take a lot of time and a lot of thinking. So the meta decision would be for the student to read, and I instruct my students to do this for exams, but it's good to do this for any set of tasks, to look at the overview of the set of tasks you need to do and sort of assign the resources. How much time am I going to spend on each question? And it may be that you got done with the first question faster than you expected, then you can allocate more resources for the future question. But it is this idea of being able to look at problems from a non-myopic sense and allocate your resources efficiently and effectively to achieve your goals.
The machine will just do that processing quickly and without emotion.
Right. The emotional aspect is taken out. There are advantages and disadvantages to having emotions in humans. So for instance, the emotion of boredom actually prevents you from learning and then relearning 100 times the same concepts. So you learn something, you know it, you move on to the next concept. And so that is, again, you're being efficient with the resources. We can embed this notion of boredom without all of the other biological markers or the underlying neural firings in the brain in a software system, but still get the same effect, right? So how do you make sure a system that is capable of learning, an intelligent agent, is quickly moving through all of the tasks that it needs to learn for?
We knew we could trust them.
In the 2004 movie I, Robot, Will Smith hates robots because a robot making a meta decision based on logic and the probability of survival rescued him from a car crash, cutting short Smith's effort to save a 12-year-old girl. The robot ran the numbers and made a decision. Our guest, Professor Raja, has a paper titled Multi-Agent Meta-Level Controls for Adaptive Traffic Systems, and in it, I did not see any mention of actor Will Smith. But the underlying issues of the movie I, Robot present actual problems that our guest is currently working on. So what does your paper say about AI accidents in traffic systems?
Yes, so our work in the application of the traffic domain is to learn how to handle dynamic traffic scenarios. Suppose there is an accident or there's a weather system or just rush hour congestion that now blocks a lane, a complete road, a highway. So how do we reroute the traffic using software agent systems so that the traffic flow is closer to normal? How do we reduce both the average travel time of all of the vehicles on the network, and also how do we reduce emissions? So that's a question that we are looking at. So because the more congestion there is, the worse it is in terms of emissions affecting our environment. And it might require multiple agents to coordinate with each other. The intelligent agents handling the traffic for the Upper West Side may have to communicate with the agent handling traffic in Midtown to make sure that we can use all of the routes.
And to have a computer who can think that is better than what a human could execute.
It's better in some ways. So it's able to do computation faster, but it's not able to bring in all of the external knowledge. It's only going to be using the knowledge for traffic that we are using in that context. A human, on the other hand, has general knowledge. They're able to understand it's the weekend or it's a weekday, that it's a holiday, it's Halloween, so traffic patterns could be different. So intelligent agents are often just focused on a particular application. It's not across all multiple applications, and they just know what they need to know to solve that problem at this point.
Because they're tools.
That's correct.
A hammer knows how to do one thing.
Yes.
Or a shoe knows how to do one thing, but sometimes you use it as a hammer.
That is true as well. Sometimes, yes.
In Free Guy, the non-playing character barista only makes coffee hot with 2 sugars until suddenly she learns to make cappuccino.
Medium coffee, cream, 2 sugars. That's what you get. That's what everyone gets every day, always.
But in real life, how does a computer learn?
So machine learning in the simplest terms is pattern recognition. So what this software does is it recognizes patterns in existing data using algorithms or statistical models, and then it's analyzing these patterns and then coming up with inferences so that it can apply these inferences or models that it has learned on new data that it hasn't seen before. Reinforcement learning is a type of machine learning where the agents explore the environment. They aren't given positive and negative examples of what is the best action to take. They actually have to explore the environment like a baby does, right? A baby in a complex, rich environment would explore the environment, and it's constantly learning what is around it and what its actions could result in. So it's a trial and error method where there are rewards for good actions and penalties for bad actions, and the system then learns what are the set of actions I need to do that will lead me to a very high positive reward. And I believe the barista is doing reinforcement learning. When you do trial and error, that's what's happening in that agent.
What constitutes a reward for a computer?
So again, when
Give it a little ounce of power?
Yeah, again, because for a computer, it doesn't have its own selfish goals, right? What it cares about is this utility function that you've given it, and it's trying to maximize this. So you say, if you achieve this goal, you get plus 10 points. And what your goal in life is to get as many of those points within the constraints of the actions that the designer has defined.
A robot cannot harm a human being.
If a machine seems to have emotion, or because it's capable of making a meta decision, does that make it self-aware? Because in movies it does, and now the AI is ready to go on a rampage.
I think when we define self-awareness or the ability of an agent to have, of a system, of a human to have conscience, we're still trying to understand the levels of what that really means. What does it mean to have a conscience? Is it just the fact that you have feelings, or more in-depth sense of morality, and so on, right? So I think we can build systems and I've done work in this area of self-aware at a very high level. So building intelligent software systems where they are introspective. So when they make a mistake, like we were talking about positive rewards and negative penalty, so now that it has got negative penalty, perhaps it can go back and see what are the choices that it made, even if it's not in a reinforcement learning context. It could be in a complex problem-solving scenario that we do this as in terms of self-introspection, where we look back at our day or our past few hours and say, what did I do right and what did I do wrong, and how can I fix what I have done wrong? And again, in AI systems, we are right now in the context of very well-defined application, and this is what we would call weak AI. So weak AI is where a software agent is an expert in a certain area or application. So it's not able to do both solve the problem of prediction in healthcare and deal with transportation. We have individual agents who are experts and learning to handle individual situations.
They cannot apply what they've learned.
They cannot generalize what they have learned. So the moment, and there are researchers looking at what is called strong AI, where we're trying to introduce this notion of a conscience and in fact it's called artificial general intelligence, AGI, where we are trying to imitate the intelligence of a human. Right now we're just taking one characteristic of what intelligent behavior would be. So chess playing, or you're doing AlphaGo. Maybe you can play a couple of games which are similar. But to say, take an AlphaGo game player AI and then try to solve something in financial informatics is not there yet.
In most utopian AI stories, the computer or robot wants to be human. I understand way back in 1985, a sci-fi movie called Daryl seeped into your programming and influenced your decision-making matrix. How did that happen?
Daryl. So that was my view of AI from the lens of a 10-year-old. So I was a 10-year-old, and the character Daryl in that is an AI system which is embodied in a 10-year-old kid. Is adopted by a family, and he goes from being this super talented ball player and a computational system.
All knowledge is learning, and therefore good.
To learning to have feelings towards his family. And I think that, from a 10-year-old's eyes, that was a very moving aspect of AI. Because the other shows that I had watched so far was like Giant Robot, which was a manga series, which was on TV. And in that case, the AI was significantly different from humans. It was this huge 40-foot robot capable of doing incredible things and was subservient to this, again, another 10-year-old kid. But it definitely got me interested in AI, and I went through doing undergraduate research in AI and a graduate school. And I quickly learned that we were very far from that embodiment of Daryl.
What am I?
Intelligent agents or robotic systems are not capable of those deep feelings or emotions, or even, as we say, this idea of conscience. But they're capable of doing some activities as well as humans do, and sometimes maybe in some cases better than humans, which is helpful for us.
In Free Guy, there's a scene that takes place in an underground room full of giant stacks of servers. And at one point, our girl Millie is willing to trade what might have been untold riches to save the data that's on one of those servers, like she's bargaining for the life of a person or a thing that she loves. Right now, we can turn our AIs on and off at will. Do you think there'll be a time when that will change?
It is true, we can turn off the AIs on and off at will at this point. And my research, and there are a lot of other AI researchers out there who sign up for this notion of building these computational societies where you have both humans and machines working seamlessly together to solve problems. So this is my North Star in research, right? So how do we get systems to assist human beings, these intelligent agent systems to assist human beings so that we can solve problems even better? Because sometimes it's not possible for us as humans to solve the problems because we don't have all of the computational capabilities that machines have. And yet the machines don't have the way we are able to approximate and generalize problem solving. And so we can help each other solve these problems. But I truly believe that these systems will always have what is called adjustable autonomy. That they should be able to opt out control to the human designer or the human users at all points. There are many AI researchers in the past decade who have now focused on the ethics of AI to ensure that when we build AI systems, that these are safe systems, right? That we have the right guardrails to make sure that these systems don't go off and say, oh, you turn me off, I'm still going to continue to be turned on. So even as I train my students, ethics in AI and ethics in ML is an important lecture that and sometimes I embed it throughout my course to make sure that students are aware of the types of systems that they are building.
Essentially, you're teaching a version of Asimov's rules for AI.
So we are teaching Asimov rules for AI for different applications, right? So there are general rules. For instance, you want to make sure you terminate, you don't want to overuse your resources, and if it's a life-saving situation, you want to define that within your utility function. We talked about value-aware decision-making, and you can insert these values as part of your utility function. That's how you communicate with your agent, right? You're trying to say what is important to it and what is not. Asimov's rules were some initial rules, but I think depending on your system, you'll have to define very specific rules to make sure it doesn't go over.
Asimov's rules are not naturally occurring. Asimov's rules have to be implemented into the system.
Yes, they are embedded in the system, which is the same as the guardrail.
So basically, the university will save the world by making sure that all of the students are well trained.
That is our hope. Yes, absolutely. For the future generation of AI scientists to understand the magnitude of what can be achieved using AI and ML, and to be very careful about how they use this ability in intelligent systems.
Anita, unfortunately, we are out of time. Thank you so much for coming by.
Thank you, Lisa. This was fun. I really enjoyed it.